Okay, so the last two concepts we're going to talk about is something called concave up and concave down. All right, now before I show it to you on the graph, I just want to show you what a concave graph that is concave up looks like. All right, so let's just say that this is our graph, okay, and we kind of look like this, okay. All right, where it is concave up is going to be where your graph is like curved upwards. So for example, right here on this graph right here, this is where your graph is concave up. So think of it as like a cup. It is concave up. All right, so you're thinking of it as like a cup and you can like drink out of that cup. Where you can drink out of the cup, it is concave up. All right, so what that means now, these are intervals. Once again, these are not points on your graph. These are intervals. They're x intervals where any tangent line that's drawn below the curve, is below the curve. So all that means is when you have a tangent line is just a line that touches your graph once. So if I was going to draw my tangent lines in, they're like little slopes of lines. This is kind of hard to see on here. I'll draw it in class. But basically, as you draw these, okay, your curve or your line that's going to touch your graph once is all below the line. So I just want you to think of this once again as a cup. It is curving up. Okay, so it curves up. And once again, these are x intervals. So these are x values only. They are not points on your graph. They are intervals from the graph. All right, so let's just take a look at our graph right here and let's figure out where my graph would be concave up or curved up like a cup I could drink out of it. And it has to be a curve. It can't be like a V, okay? So it's a curve. You never drink out of a V-shaped cup, right? So if you take a look right here, this graph is concave up, okay? This is curved up from what x interval? So from x starting at 1 going until x is equal to 5. So we're looking at what x intervals, okay? So this is going to be 1, comma 5. And here you are never going to use brackets. Okay, and it's sort of the same reason that you're not using brackets before. There are points where they change, and at those points, okay, it's neither concave up or concave down. It's just sort of like the start of it. All right, now concave down, okay, is basically like the opposite, right? So let's take a look at that same sort of graph that you're kind of thinking about. And here, this is concave up because it's like a cup. Concave down, think of it as like you're sitting on top of the hill. So any line that is tangent to the curve that you would draw would be on top of the curve. And I'll explain that more in class, but just kind of remember, so this is sort of like thinking of a like the top of a hill. Okay, once again, these are x values, and you're looking at what x values on your graph is it concave down. All right, now if we take a look right here, okay, this is going to be where my graph is concave down. All right, so it is concave down starting from here all the way until this point. Now you're going to think of what x values here. Now our graph is actually going from negative infinity all the way until this x value is -3. So from negative infinity all the way until we hit x is equal to -3, my graph is concave down. All right, so we're going to go from negative infinity to -3. All right, there's another point on my graph where my graph is concave down. If you notice, starting right here, it looks like it's going downhill. Okay, at what x value did that start at? That started at x is equal to 5. Make sure you include your union symbol. Okay, and it's going to be concave down. Looks like it's going down a hill, like a hill, all the way forever to the right, which would be to infinity. Okay, now a point of inflection. Notice how this says point. So this is a point on your graph. So this is going to be an x comma y ordered pair. All right, so it's not an interval, it's a specific point on your graph. Now a point of inflection is where the graph changes from concave up or concave down. There are no other places on the graph that is going to be called a point of inflection. So let's take a look at this. So if you notice here, my graph is going concave down. This looks like it's down a hill. At this point right here, it stops being concave down. However, it does not start being concave up. So this is not a point of inflection. Okay, because now I just have what looks like a slope going upwards. Okay, another slope going upwards. Okay, this also is not a point of inflection because this was not concave up or concave down. These were just segments of line being put together. This is where my graph started being concave up or curved up. Now, if you notice, as I go from the green to the red, so this right here is concave up and this right here is concave down. When they're connected, you have to find the point where they change from being concave up to concave down. So on my curve right here, it went concave up, okay? And at this point right here, okay, my graph started to look like it was going to turn and go concave down. Now, I understand that this might be an estimation. You will not be able to find this exact point until you get to calculus, but this is just an estimate right here of where it sort of changes from looking like a cup to looking like a hill, okay? And at this point, this is 1, 2, 3, 5, 4. And like I said, that is just an estimate, all right? Okay, if you have any questions, let me know, and we'll be going over this in class.